Assalamu alaikum class. In this lecture we will learn how to resolve collision using open addressing technique. First of all, let's recall what is collision. It is an event in which two data elements maps into the same slot in the array. So what to do when collision happens? There are two methods, separate chaining and open addressing. We have already studied what is separate chaining. There are certain drawbacks in separate chaining technique. So today we will explore what is open addressing and what are its advantages and disadvantages. In open addressing, if collision happens, we try alternative cells until an empty cell is found. The first way to resolve collision in open addressing is linear probing, in which we can search the next empty location in the array by looking into the next cell until we find an empty cell. This technique is called linear probing. Try next available position. Now let's solve an example to get better understanding how linear probing works. For example, user tried to insert 12 in this hash table. The total size of the table is 11. 12 mod 11 is equal to 1. So hash function return 1. As you can see that first location is already filled, so collision occur. What we're going to do, we're going to try next available slot. We will probe for next slot. So after 1 we will check the second index. Second index is already filled. Again collision occur. Then we will check the third index. Again collision occur. Then we will try the fourth index. Fourth index is empty. We will insert 12 at fourth index. So if collision occur, we will be using this formula in linear probing, h of x plus I, where h of x is hash function and I is total number of collision. First time when we try to insert at first location, the number of collision is 1. So the value of the hash function was 1. 1 plus 1 is equal to 2. And we will try the second index. At second index, again collision occur. This time number of collision is 2. So the value of the hash function was 1. 1 plus number of collision, that is 2. 1 plus 2 is equal to 3. Now we will check the third index. Again collision occur. Total number of collision is now 3. So 1 plus 3 is equal to 4. Now we will check fourth index, that is empty slot. Data will be inserted at fourth index. So how we are going to search an element if we have used linear probing to resolve collision? First we will compute hash function and search that element on the hash function value. If value is found, then you are done. Else, keep searching it on next location and terminate search when found an empty location. For example, if user want to search 15, first we will compute hash function 15 mod 11 is equal to 4. Now we will compare 15 with the value at fourth index. 15 is not equal to 12. Now we will use the same function that we have used while inserting h of x plus I, where h of x is hash function and I is number of collision. So the value of the h of x is 4 plus total number of collision occurred till now is 1. 4 plus 1 is equal to 5. Now we will check the next location, that is 5, and we will compare 15 with that value. 15 is also not equal to 16. Now we will try the next location. 4 plus 2, number of collision is 2 now. 4 plus 2 is equal to 6. Now we will try next location, that is 6. 15 is not equal to 28. 4 plus 3, number of collision is 3. 4 plus 3 is equal to 7. Now we will try next position, that is 7th index. 15 is not equal to 7. Total number of collision that has occurred till now is 4. 4 plus 4 is equal to 8. Now 8 is an empty location, that means your value is not found. Deletion in hashing with linear probing. Standard deletion does not work here because we were using empty bucket as a sign to terminate search operation. So one simple idea is not to delete but mark. While inserting, we will put an item in first empty or marked bucket. While searching, we will continue parse marked bucket and we will terminate search until an item is found or we found an empty slot. While deleting, we will just mark the bucket as deleted. The disadvantage of this approach is that table can become full with a lot of dead items. Deletion with linear probing. For example, if user want to delete 9, first we will compute hash function. 9 mod 11 is equal to 9. Now we will compare a 9 with the value at 9th index. 31 is not equal to 9. Now we will try next available position using the linear probing formula h of x plus I, where I is number of collision. Total 1 collision occur. 9 plus 1 is equal to 10. Now we will check 10th index. 9 is equal to 9, value is found. Now instead of deleting, we will just mark that slot with D. One problem with linear probing technique is the tendency to form cluster. A cluster is a group of items not containing any open slots. The bigger a cluster gets, the more likely the new value will hash into the cluster and make it even bigger, and cluster cause efficiency to degrade. For example, if user want to search 28 from this table, then first we will compute hash function. 28 mod 10 is equivalent to 8. We will check 8 index collision occur. Number of collision is 1. Then 8 plus 1 is equal to 9. Again collision occur. 8 plus 2 is equal to 10. And 10 is greater than table size. We will take mod with table size again. 10 mod 10 is equal to 0. Now we will check 0th index and again collision occur. Similarly, we will check first index, then second index, and then at the third index there is an empty slot. It means that 28 is not present in this hash table. We were trying to store the data in the array in a constant time or in a single step. Similarly, the find and remove operation should be of constant time. That was the attribute of hashing, and that attribute has been lost. As you can see, this table has 5 items. So while searching 28, we have to check half of the hash table, that is no longer constant time. One of the solutions that solves the clustering problem in linear probing is quadratic probing. In quadratic probing, first we will compute hash function. And if collision occurs, we will check h of x plus 1. If again collision occurs, then we will check h of x plus 4. Then h of x plus 9 and so on. So instead of using I, we will use I square. So the formula to resolve collision is h of x plus I square. And if the resultant value is greater than table size, then we will take again mod with table size. Now let's try to insert a value in this hash table using quadratic probing. We will try to insert 12. Total size of the table is 11. So 12 mod 11 is equal to 1. At one index, as you can see, collision occur. So now we will compute the formula of quadratic probing, that is h of x plus I square, and the value of h of x is 1 and the value of I is 1. So 1 plus 1 square is equal to 2. Now check second index, again collision occur, the value of h of x is 1 and number of collision is 2. So 1 plus 2 square is equal to 5. Now we will take fifth index, again collision occur, number of collision is 3. So 1 plus 3 square is equal to 10. Now we will check 10 index, not an empty slot, again collision occur. Now 1 plus 4, 4 square is equal to 16, 16 plus 1 is equal to 17. Now 17 is greater than table size, we will take again mod with table size. 17 mod 11 is equal to 6. Now we will check 6th index, again collision occur. Number of collision is 5. 1 plus 5 square is equal to 26. 26 is also greater than table size. So again take mod with table size. 26 mod 11 is equal to 4. Now we will insert 12 at fourth index. So in linear probing, we were checking next empty slot, but in quadratic probing, somehow data gets scattered with I square.